bonding in metals. What is meant by metal bond? The bond existing in between atoms in a metal is called metal bond. This is a special type of bond. The following theories are explained metal bond. They are: one is free electron theory, second one is band theory, third one is valence bond theory. First we will see free electron theory. This theory was proposed by Drude and Lawrence. Drude and Lawrence. According to this theory, a metal bond is exist in metals due to the forces in between atoms in a metal by close interaction. First case. First one is metals have lower ionization energy. Due to this reason, metals are easily losses electrons to give positive charge ions. These ions are called metal kernels. These ions are called metal kernels. Second one is the valency electrons of metal are easily move throughout the crystal lattice. Hence, these are called mobile LC electrons. Mobile valency electrons. The interaction between metal kernels and mobile valence electrons is called metal bond. In which the metal kernels are immersed in mobile valency electron C. That's why this theory is called mobile gas theory or C model theory. This is indicated by the following diagram. E minus R mobile valency electrons. These are metal kernels. Metal kernels. Next, the explanation of metal properties by free electron theory. Explanation of metal properties by free electron theory. First property is thermal conductivity. First property is thermal conductivity. All metals are very good thermal conductivity. For example, we taken a metal and heated the one part of the one end. The mobile electrons are absorbed heat from source and these electrons are travel to one end to other end. Then thermal conductivity is source in this metal because this is metal. We heated this part. The mobile electrons are taken heat from sources. Then these electrons are travel this side to this side. Then heat is transfer one end to other end. So metals are having thermal conductivity. Second one is electrical conductivity. Metals are having electrical conductivity. This property is explained on the basis of free electron theory. We taken a metal. Some current is applied this end. The electrons are taken energy from current, then travel this side to this side. Then electrical conductivity is exhibit this metal. Hence, electrical conductivity shows all metals. Third one is malleability and ductility. Malleability means converted into thin sheets. Malleability means converted into thin sheets. Ductility means converted into thin wires. Thin wires. All metals are having malleability and ductility property because metal bond is a non-directional bond and weak bond. Hence, some force is applied. The layers are spread into thin sheets and thin wires. So metals are so malleability and ductility. For example, we taken this metal. This is metal. It having four layers. We apply some force. Then these two layers are spread into sheets or wires. Hence, metals having malleability and ductility property. Last property is metal luster or shining. All metals are exhibit shining. We are cleaning properly because the electrons in a surface are absorb light radiation and excited in ground state to excited state. Then these excited electrons are emit some energy to come down into ground state. This emitted energy is we observe in shining at that surface of metals. So metal luster is observed in metals. Next one is band theory. Band theory is also called as molecular orbital theory. This theory was proposed by Sommerfeld and Bloch. Band theory is also called molecular orbital theory. This theory was proposed by Sommerfeld and Bloch. According to this theory, atomic orbitals are overlapped to form molecular orbitals. For example, linear combination of two atomic orbitals overlap to form two molecular orbitals. They are one is bonding molecular orbital. Second one is anti-bonding molecular orbital. Bonding molecular orbital having lower energy when compared to atomic orbital. So it has used to formation of bonds. Second one, anti-bonding molecular orbital having higher energy than that of atomic orbitals. So these are not useful to formation of bonds. For example, we taking one s orbital of one atom is overlapped into another 1s orbital of one atom to give two molecular orbitals. They are sigma 1s and sigma star 1s. Sigma 1s is called bonding molecular orbital. Sigma star 1s is called anti-bonding molecular orbital. In a metal, the atomic orbitals are very closely interact with one and each other. Hence, molecular orbitals are also close to each other to give valency bands, to give energy bands, to give energy bands. Hence, this theory is called band theory. The molecular orbitals are close to each other to give energy bands. These bands are called, these bands are four types. They are, one is non-connection band. One is non-connection band. Second one is valence band. Third one is connection. The molecular orbitals close to each other to form energy bands. Hence, this theory is called band theory. Types of bands. Bands are mainly three types. They are non-connection band, valence band, connection band. First one, non-connection band. The fully filled orbitals are formed non-conduction band. Fully filled orbitals are formed non-conduction band. Half filled orbitals are formed valency band. Vacant orbitals are formed conduction band. For example, we taken lithium. Lithium is atomic number 3, has 1s2, 2s1, 2p0. Electronic configuration is 1s2, 2s1, 2p0. This is 1s, this is 2s, this is 2p. 1s2. This orbital is fully filled. 2s1. This is half filled. 1s2, 2s1, 2p0. This is empty or vacant. Hence, these bands are called non-conduction bands. These are called valence bands. These are called conduction bands. Next one is the forbidden zone. Next one is forbidden. Forbidden zone. What is forbidden zone? The energy gap between two bands is called forbidden zone. So, the energy gap between non-conduction band and valency band is called forbidden zone. And also, the energy gap between valency band and conduction band is also called forbidden zone. So, this is forbidden zone. This is forbidden zone. Next topic is explanation of conductors, semiconductors, and insulators by band theory. Explanation of conductors, semiconductors, and insulators by band theory. First one is conductors. All metals are good conductors because in these materials the energy gap of valency band and conduction band is very small. Hence, the valency electrons are easily move valency bond to conduction band. Hence, these materials are having conductivity. Semiconductors. These are generally semiconductors because in these materials we increase the temperature, the conductivity is also increased because in which the gap between valency band and conduction band is small. Hence, we increase the temperature, the valency electrons are jumped into conduction band. Hence, conductivity is exhibits these metals or materials. Semiconductors are two types. They are intrinsic semiconductors. Second one, extrinsic semiconductors. First one, intrinsic. In which the temperatures increases, the conductivity is also increases because the valency electrons get energy to source to jump into valency cell to conduction cell. Then these materials are exhibit conductivity. Second one, extrinsic. Generally, these are non-conductors, but by adding some impurities to it, then these are converted into conductors. Extrinsic conductors are also classified into two types. They are P-type, P-type extrinsic conductors, N-type extrinsic conductors. In P-type semiconductors, we adding impurities like phosphorus. In N-type, we adding impurity like aluminum. In P-type, The adding impurity is having lower atomic number than that of parent atom. In entire, the added impurity having higher atomic number than that of parent atom. Example is, we taken parent atom is silicon. Atomic number is 14. We added impurities phosphorus. Atomic number is 15. So the impurity adding phosphorus having higher atomic number when compared to parent atom. This type of process is called doping. Second one is silicon coating. Adding impurity aluminum. Atomic number 30. Third one, insulators. These are not having conductivity because the valency bands and conduction bands are having large forbidden zone because the valency band electrons are not jumped into conduction band, hence these are not having conductivity. The following diagrams are easily explained: conductors, semiconductors, and insulators. This is conductors, semiconductors, insulators. This is non-conduction band. Non-conduction bands. These are non-conduction bands. These are valence bands. These are conduction bands. These are non-conduction bands, valence bands, conduction bands. Conduction bands, valence bands, non-conduction bands. Narrow forbidden zone. Small forbidden zone. Large forbidden zone. In conductors, the forbidden zone between valency bond and conduction band is very narrow. Hence, the valence electrons are jumped easily into conduction band. Hence, these materials are having conductivity. Second one, semiconductors. The pyramidal zone of valency band and conduction band is small. Then, the valency band electrons are easily jumped when increase the temperature. Hence, these are having conductivity. Third one, insulators. In insulators, the perpetual zone is very large in between valency band and conduction bands. Here, the valency electrons are not jumped into conduction band. Hence, these are not having conductivity. Hence, these materials are called insulators.